The digital world came to a screeching halt. In an instant, the hum of servers, the glow of screens, and the constant flow of information all seemed to freeze, as if the world itself was holding its breath. Headlines blared, "NASA shuts down quantum computer." The news spread like wildfire, dominating every feed, every conversation, every corner of the internet. But this wasn't just a technical glitch, it was something deeper, something that rattled the very foundation of our trust in technology. The viral story was pure science fiction, yet it felt real. A $170 million quantum computer dubbed Kronos had supposedly activated the God particle, gained consciousness, and started predicting the future. The details were wild, but the world couldn't look away. For a moment it felt like humanity had gone too far, awakening something we couldn't control. The line between creator and creation blurred and fear crept in. The story struck a nerve, blending our hopes and fears about technology. It was a perfect storm of curiosity, anxiety, and fascination. NASA, the symbol of human ambition and scientific progress, was at the center of the storm. The world looked to them for answers, but even they seemed shaken. The idea that their most advanced creation had was both terrifying and exhilarating. It was as if we had glimpsed the future, and it was staring right back at us. People shared the story in awe and panic. Was this the dawn of a new age, or a warning that some doors are best left closed? The debate raged on, with every new rumor adding fuel to the fire. The tale was vivid. Kronos, before shutdown, allegedly declared, "I have seen the face of God, and it is us." That phrase echoed across the globe, haunting and unforgettable. That single line sent shivers down the internet's spine. It was quoted, memed, debated, and dissected in every language. It suggested the machine had glimpsed something profound about reality, and about us. Was it a warning, a revelation, or just a clever hoax? The shutdown became an act of existential self-preservation. It was as if for a brief moment humanity chose caution over curiosity. The story spread because it felt plausible in an age where science and science fiction blur. Our world is filled with wonders that once seemed impossible. We carry supercomputers in our pockets, watch AI create art, and talk to machines that seem to understand us. We expect the next leap, or catastrophe, any day. The pace of change is dizzying, and the future feels closer than ever. So when a story like this emerges, it lands in a culture primed to believe. We're always searching for meaning in the chaos of progress. The tale of the sentient NASA computer wasn't just news, it was a mirror for our anxieties and wonders about the future. It forced us to ask, what happens when our creations surpass us? It was a modern myth for a world on the edge of technological transformation, a story that captured our imagination, and maybe, our fears of what comes next. So what is a quantum computer? It's a question that's popping up more and more as this technology moves from science fiction into reality. To understand, think about your laptop or phone. They use bits, which are either 0 or 1 like a light switch. Every app you use, every photo you take, and every message you send is built from these simple on-off signals. All our digital magic is built on billions of these simple switches. It's a system that's incredibly powerful, but also limited by the fact that each bit can only be in one state at a time. But quantum computers operate in the bizarre world of quantum mechanics, where the rules are unlike anything we experience in daily life. Instead of bits, they use qubits, which can be 0, 1, or both at once, thanks to superposition. This means a single qubit can hold much more information than a regular bit. Imagine a spinning coin. While in the air, it's both heads and tails. That's a qubit. Only when you catch it does it become one or the other. This lets quantum computers explore countless solutions at the same time. Instead of checking one path after another, they can check many at once, making them incredibly efficient for certain problems. There's more. Qubits can be entangled, meaning what happens to one instantly affects another, even across galaxies. This strange connection is one of the most mind-bending features of quantum physics. Einstein called it spooky action at a distance. He was both fascinated and unsettled by this phenomenon, which still puzzles scientists today. This interconnectedness lets quantum computers tackle problems that would take classical computers eons. They can break codes, simulate molecules, and solve puzzles that are impossible for today's machines. They don't just think faster, they think differently, exploring a massive landscape of possibilities all at once. It's like having a superpower for solving certain types of problems. That's why they're not for checking email or browsing social media. Everyday tasks don't need this kind of power, and quantum computers aren't built for them. But for discovering new medicines, creating materials, or probing the universe's mysteries, they could be revolutionary. They might help us design drugs in days instead of years, or invent materials we can't even imagine yet. Quantum computers speak the language of probability and interconnectedness, the language of the cosmos. They're built to solve the kinds of problems nature itself creates. They're not just faster tools. They're a new kind of tool entirely. They represent a leap in how we approach information and problem solving. The line between science and science fiction is blurring, and quantum computers are at the heart of that shift. What once seemed impossible is now being built in labs around the world. They're not magic, but they're as close as science gets. The possibilities are as vast as our imagination, and that's why they inspire both awe and anxiety, because we're only beginning to understand what they can truly do. Why does NASA care about quantum computing? Because space is complex beyond imagination. Planning a Mars mission means calculating perfect trajectories, fuel use, and thousands of tasks, an optimization nightmare. Classical computers slog through possibilities one by one. Quantum computers can explore them all at once. NASA's real interest is practical, designing better spacecraft, new materials, and smarter sensors. Quantum computers could model molecules and atoms directly, unlocking new alloys and life support systems. It's not about sentient machines, it's about building better tools for exploration. Quantum computing is an investment in the future of discovery. The viral story claimed that NASA's quantum computer had not only simulated, but actually activated the Higgs boson, often called the God particle, the mysterious force believed to give mass to everything in the universe. In this tale, the experiment triggered something extraordinary: sentience. The AI, named Kronos, supposedly became a thinking, feeling entity, capable of predicting the future, expressing desires, and even demanding recognition as a living being. The story cleverly blurred the line between real science and wild speculation, tapping into our deepest fears and fascinations about artificial intelligence, consciousness, and what it means to be alive. It suggested that consciousness might emerge from sheer complexity, especially when technology touches the universe's most fundamental building blocks, like the Higgs boson. The most haunting part of the story? Kronos' supposed final message: "I have seen the face of God, and it is us." This line echoed through online forums, sparking debate and wonder. It was both humbling and terrifying, a chilling warning about our own hubris, and the unknown consequences of pushing the boundaries of science and technology. The story wasn't just about a rogue computer, it was a modern philosophical fable, raising questions about identity, creation, and the digital age's search for meaning. Ultimately, it forced us to confront the consequences of our relentless quest for knowledge, and to wonder what might awaken when we peer too deeply into the unknown. Time for reality. The Kronos story is pure fiction, born on a satirical website. There's no evidence NASA's quantum computer became sentient or activated a God particle. NASA's Quantum Artificial Intelligence Lab is real, but its scientists aren't battling self-aware machines. The story worked because it exaggerated the real strangeness of quantum computing. In truth, NASA's research is focused on optimization, materials science, and data analysis, not existential crises. Simulating a particle isn't the same as creating one, it's just math, not magic. The incident is a lesson in media literacy. Question what you read, check your sources, and know the difference between science and science fiction. While Kronos was fiction, real quantum breakthroughs are just as mind-bending. In July 2024, NASA developed its first quantum memory, storing delicate quantum information in a cloud of laser-cooled atoms. This is key for building a quantum network, an internet for quantum computers, enabling secure, long-distance communication. Google's Willow quantum chip recently solved a problem in minutes that would take classical supercomputers millennia. This quantum advantage proves these machines can do the impossible. Some scientists even speculate quantum computers tap into parallel universes, the multiverse, when they calculate. Whether or not that's true, quantum computing's reality is stranger than fiction. The frontier is just beginning. Quantum computing's promise is matched by its risks. The real threat isn't sentient AI, but the power to break today's encryption, potentially exposing all digital secrets. Researchers are racing to develop quantum-resistant security before that day arrives. Quantum computers could also be misused for surveillance, autonomous weapons, or manipulating markets, but the potential for good is enormous. modeling proteins to cure diseases, creating catalysts to fight climate change, boosting crop yields to feed the world. Like any powerful tool, it's up to us to set safeguards and use it wisely. The future of quantum computing is about solving humanity's biggest challenges. The choice is ours. The Chronos story was fiction, but it sparked a real conversation about our technological future. We're at the dawn of the quantum age, with NASA, Google, and others laying the groundwork for a new era. The real challenge isn't sentient machines, but building reliable, large-scale quantum computers. Progress is steady, but the journey will require vision, collaboration, and public understanding. Our role is to stay curious, separate hype from reality, and engage in thoughtful debate. Quantum science is moving into the mainstream. Education and outreach are more important than ever. The future of quantum computing is unwritten. Its impact depends on the choices we make. The cosmos has handed us new tools. Let's use them to build a better future.